Okay, so now what we're going to do is we're going to take what we've learned about finding bounds on a Taylor and Maclaurin series, and now that we know how to find those bounds, now we're going to use that to show that a Taylor series converges, and it converges, well, a Taylor series of f, so given a function, that if we can have a Taylor series of f at a, then we can use the fact that it's bounded, and we can find, the fact that we have r sub x, right, and we can find that, and it's bounded, we can use that to show that the Taylor series converges to f, okay? And so we're going to start by basically looking for, starting with the idea of finding representations, Taylor series representations and Maclaurin series representations for functions. Okay, so let's start with that, and then of course, in addition to that, showing finding the interval of convergence. Okay, so that's what we're going to start doing, and so let's find the Taylor series for this function. So we have f of x. So f of x is equal to 1 over x at x equals 1. Okay, and so we want to find a Taylor series for this function, and we want to determine the interval of convergence. Okay, so now we want to find the values of the derivatives. Okay, so let's list the first 4 derivatives of this function. Okay, and then we'll evaluate them at x equals 1. So we got 1, 2, 3, 4. Okay, so the first derivative of this would be negative 1 over x squared. And the second one would be 2 over x cubed. And the next one would be negative 6 over x to the 4th. And then we would get positive 24 x to the 5th. Okay. And so we could write this also as 3 times 2. And this one we could write as 4 times 3 times 2. Okay, or to make it more obvious, we could do this, right? And then we have f, well, if we have f of 1, that's just equal to 1. How do I want to do this? Let's do it. Yeah, that's fine. That's fine. So we have f of 1 equals 1. F prime of 1 is going to be negative 1. And then f double prime of 1 is going to be 2 factorial. And then f triple prime of 1 is going to end up being equal to negative 3 factorial. And then f of 4 of 1 is going to be 4 factorial. Okay, now, so what we have is, we can see a pattern here. So if we use f to the nth derivative, right? The nth derivative of f of 1, then we get an alternate series that looks like this. So we get f of n of 1 is going to end up being what? Negative 1 to the nth power times n factorial. And this is going to be for all n greater than or equal to 0. And so now we can write the Taylor series for f at x equals 1 given by this series. And so the Taylor polynomial, how do I write this? Okay, so I'll just write it with sigma notation. So it's going to be equal to n equals 0 to infinity of f to the nth power of c, or no, I'm sorry, 1. We want to use 1 here. 1 over n factorial times x minus 1 to the nth power. And so if we plug this in, what do we get? Well, this is going to be equal to n equals 0 to infinity. Well, f to the n of 1 is just this. So this is going to be negative 1 to the nth times n factorial over n factorial times n minus 1 to the nth. And then, of course, the factorials are going to cancel. And we get our final expression, which is going to be the summation from n equals 0 to infinity of negative 1 to the nth times x minus 1 to the nth power. And to find the interval of convergence, we just use the ratio test. And if we use the ratio test, we'll find that the absolute value of the ratios equals the absolute value of x minus 1. So if we use the ratio test, we'll find that the ratio of the absolute values will actually give us the absolute value of x minus 1. And that tells us that the series converges if this absolute value is less than 1, right? By the ratio test. And so that means this series converges when what? When x minus 1 is less than 1 or greater than negative 1, which means that when x is less than 2 and greater than 0. And so the next thing we have to check is the endpoints. So at x equals 2, okay, so here so far we've got this as the interval of convergence. But now if we check 2, well, when this is equal to 2, what happens? Then we get 1 to the n, which just gives us negative 1 to the nth power. So that's just an alternating series that's divergent. It doesn't converge to anything. Okay? So, and we could show that by the divergence test. And then similarly, when x is equal to 0, so when x is equal to 0, you get negative 1 to the n times negative 1 to the n. And so what does that give you? Well, when you combine those together, you're going to get 1. Okay? You get negative 1 to the 2n power, which is just the summation of 1 from n equals 0 to infinity, which is just which also diverges. Right? Because that just becomes n times 1. So as n goes to infinity, it's going to diverge. So in that case, it diverges at both endpoints, and so the radius of convergence is going to be 0, 2. And that's it. Have a great day.